In this lesson, we're going to be talking about boot processes. Now, boot processes are the way that a system gets started up and the operating system gets loaded and all of the initial programs actually get started up in the correct order and sequence. So let's take a look at a process that would be used to boot Windows as an example. So when we're booting Windows, the very first thing that we're going to be doing is to look at the master boot record, and the system BIOS, which is firmware that resides on your system's motherboard, is going to do this looking at the master boot record. The master boot record actually has a set of code where the initial loader is stored. So there's 440 bytes in the master boot record, and actually what I've got up here in WinHex is the first sector of this particular hard drive, which would have the master boot record in it. And as I said, there's about 440 bytes in the master boot record that tell the firmware how to actually load the operating system. So the firmware is going to go to the master boot record. It's going to kick off this boot code that's stored in the master boot record, and the boot code is actually going to go load the actual operating system, in this case, Windows. Now, once the operating system is loaded or getting loaded up, there are going to be a series of events that happen that get the system services and other programs loaded. So I'm going to load up the services management console here in Windows, and you can see there are a number of services that are installed on this particular system. And so we've got some that are set as an automatic startup. So as soon as the system starts up and gets to the point where it's going to do some initialization of different services, it's going to go through and find all of these automatic start services, and it's going to load those. So now we've got a bunch of system services, like, for example, a DHCP client, or we've got a DCOM server process loader. There's some services around zero configuration. There's a DNS client. There's all sorts of services that get started up under Windows. And the operating system, once it's been booted up into memory, will actually kick those off. Now, in addition to the system services, we've got a couple of other places that the system will go to in order to find programs that need to be run. The first one is there is a registry key inside HKey local machine in the registry, and we've talked about the registry in a different lesson. Now, inside that registry key in HKey local machine, if you go digging around a little bit, you will find one called run, and that's programs that will get run when that particular user logs in. In addition to that, we've actually got a folder here, and that folder is called Startup, and this is also where programs will get stored that want to be run when a user logs in. So anything you put into the Startup folder, any shortcut you put into the Startup folder, is going to get kicked off when you logged in. So all of those programs will get started as well. Now, with Unix-like operating systems or Linux, there's actually a piece of code called the bootloader, and that may be Lilo or it may be Grub. We can actually see that if I go into boot grub on this particular system. So we've got this program called Grub, and Grub will actually load the operating system. So again, we've got the master boot record. The master boot record will have a set of code from Grub that will go and find the actual kernel or the operating system on the hard drive, and it will kick off the loading of that. So once that's in place, there is a program that gets started called init, and init will go and then start a series of processes that in this case you'll see inside of init.d, where we've actually got these specifically right here are the ones that will be started at boot time. So anything that starts with an S is going to get started at boot time. And I don't see any here that start with K, but anything starting with K has to do with when the system shuts down. And that wouldn't actually be in this particular run level. So with Unix-like operating systems, there's a series of run levels, and based on the run level, you'll get a different series or set of programs that start up at boot time. So that would be Unix-like operating systems. And so far, we've been talking about the master boot record. And as I said, the master boot record has a small piece of code in it that goes and launches the operating system itself or loads the kernel. Now, current systems actually have something called EFI rather than the master boot record. And the EFI is Extensible Firmware Interface. And what EFI does is it uses a boot manager, and instead of the partition table in the master boot record, we have a GUID or a GUID partition table. The reason why we have this is because it gives us some flexibility on larger hard drives. So hard drives that are greater than 2 terabytes, we can actually use those to boot from with EFI and the GUID partition tables. So there's a boot manager when you're using EFI, and the boot manager actually could be auto-detected by the firmware if it lives on a particular path on the hard drive. So older systems have the master boot record, and that sort of dictates how a system is going to be booted or what operating system is going to be booted. On some more recent systems, we've got these EFI systems, and the process for that eventually is the same other than the way that the boot code is originally loaded, which then goes and loads the actual operating system. So we've got the master boot record and we've got EFI systems, and those are the entry points into how we get the operating system loaded and all of the system software started up.